We don't want to fail even, not late graduate. Oh no. Oh no! Oh yeah, okay. Here we go. All right, we are going to factor this. So we say, okay, what kind of factoring are we looking at? Because there's different types, right? Greatest common factor, different things. It's quadratic, so it's quadratic. So we do, oh, there's nothing in common right now, so we do what multiplies to be a times c, adds up to be b. A times c, what multiplies to be negative 10 and adds up to be negative 3, correct? 5 times 2, negative 5 times 2 is negative 10, and negative 5 plus 2 is negative 3. We cannot quick factor, our a value is not positive 1, so we drop. And we break. Rewriting negative 3x as negative 5x and positive 2x. You can reorder in any order you want. This is the order I saw most people. So then we group the first two terms, we group the last two terms, we always group this sign. What's the greatest thing in common here? X, left is divide by x, divide by x. So left is 2x minus 5, correct? What's in common here? Don't say nothing. 1. Positive 1. You can't ever not have something in common. Positive 1. So we divide by 1, divide by 1. Don't we get 2x minus 5? Is your safe haven the same? So you've done it correctly. Now we can factor out 2x minus 5. So then it divided out and left us with x plus 1. So those of you that made an error, do you see where you made it? If you reordered these, that would have been totally fine. We would have just had different, we would have come out the same here. Do I need to do that? Did anybody switch these and then not get it right and they don't know how come? We're all good? You guys, I mean, we're going to be testing it. If you can't factor, you're going to fail the test. Okay. All right, here we go. We're going to practice with that today. So first of all, I just want to say one thing here. We have to know what rationalizing a denominator is. So if you ever get an answer, we're going to be dealing with, remember with right triangle trig, we came out with like answers like this, right? Here's the rule though. You would never ever see that answer on an ACT because do you notice something that there's a radical in the bottom of a fraction? Guys, that's not considered simplified. Literally, this would not be an answer. On the ACT, they would flop those and then you would say, well, that's what I got. I must just have flopped them and you would just get the wrong answer. Because that is our answer, it's just not in the most simplified form. So you would simplify and say, I know my answer's right, we can't have a radical in the bottom, so I'm going to rationalize the denominator. So I'm going to multiply by the square root of 3 over the square root of 3. Now understand, understanding is what's going to help you remember this. First of all, the reason we're able to do this is because isn't anything divided by itself a 1? Are we just multiplying by a fancy 1 here? You get what I'm saying? So we're not changing the problem, we're just multiplying by 1. Anything times 1 is still itself. We chose a fancy 1. Now you multiply straight across, you cannot multiply something that's not under a radical with something that is. So you would leave it on top as 2 square roots of 3. That's 2 times square roots of 3. On bottom we have the square root of 9, which is what? 3. So we have 2 square roots of 3 over 3. So on the ACT, you would then select this answer. But do you see how if you saw this and then they would have on the ACT the square root of 3 over 2, you might say, well, I don't see that answer, so it must be this, and you'd get it wrong. You get what I'm saying? You just have to make sure your answer is simplified. Okay, I'm trying to help you. All right, sweet. Moving on. This answer would not be acceptable, and we're going to see these today. That's why we're going over it as well. But from here on out, if we ever get an answer, you better check. We can't have a radical in the bottom of a fraction, so we're going to multiply by the square root of 3 over the square root of 3. So on top, we have negative 3. We can multiply those together because they're both underneath the square root. So we have square root of 6 all over the square root of 9, correct? Which is 3. Now look at your answer. Can that and that divide out? Yes. 3 over 3 divides out to be 1 over 1. So won't our answer just be negative square root of 6? Negative 1 square root of 6 just is negative square root of 6. Anything divided by 1 still itself. You see how that's simplified, and you see how different that looks than the original answer. Same thing, but this is simplified. Okay, next one. We're going to multiply by the square root of 3 because that's on bottom. Does everybody see what I'm doing? So on top we have 7 square roots of 6 times 3 is 18. On bottom we have negative 2 times the square root of 9. So isn't that negative 2 times 3? Right? Which is negative 6, so I'm going to write that. 7 square roots of 18 over negative 6. Can I divide 18 and 6? No, this is under a radical. This isn't, right? So it's tricky. But here's our next step. Still not simplified answer. Here's why. You would say to yourself, I better make sure that the square root of 18 doesn't simplify. So let's see here. 9 times 2, 3 times 3 is 9, right? So won't this be 3 square roots of 2? So this became 7 times, not that, but 3 square roots of 2 all over negative 6. Isn't that 21 square roots of 2? 7 times 3 is 21 all over negative 6. Now you keep simplifying. Do both of those divide by 3? Yep. And we would never write a negative on bottom of a fraction. They just would not do it as a simplified answer. So I'm going to divide both of those by, divide by negative 3. This becomes 2. This becomes negative 7. You see how I did there? Negative 7 square roots of 2 all over 2. And that's just secondary math 3 level of simplification. Questions on that? Okay, moving on. Today we're going to be solving a quadratic. Okay, so we've been factoring quadratics, and now today we're going to actually go ahead and solve them. Not just factor them, but completely solve them. So there's so many different methods, and I just want to say one more thing. You guys literally spent like 2 months in secondary math 2 on quadratics. We're going to spend 1 day reviewing it. So we've got to like fly. Ready? Brace yourselves. Okay, here we go. I'll do a lot of examples off of your worksheet. Does that sound fair? To be nice? Okay. Well, I did. I see it all. Okay. All right. So solving by graphing. Now understand, there's many different. Listen, so you understand. There are many different methods to solving a quadratic. We learn all of them so that we can choose the easiest when we can. So first of all, the first thing we're going to do is solve by graphing. What you need to understand, when you solve a quadratic, what you're finding is where it crosses the x-axis. So solving by graphing, all you'd have to do is graph it, see where it crosses the x-axis. Now we will only solve by graphing if it crosses in exact locations, meaning whole number roots. If it has whole number zeros, where it crosses is the whole numbers. So everybody, what you would do is type into your calculator x squared minus x minus 2. You'd hit graph. You would look, is it crossing at, this is the graph. I graphed it for you. Do you see how it's crossing at -1 and 2? Exactly. Those are our solutions. X is equal to -1 and x is equal to 2. So solving by graphing is the easiest. We just can't always use it. Does that make sense, everybody? Okay. So solving these by graphing. So if we were to graph this in our graphing calculator, it'd look like this. Where is it crossing at? 0 and? So our solutions are x is equal to 0 and x is equal to -2. Now one more thing, quadratics always have 2 solutions. Do you see how it's crossing twice? That is still true. If we had a quadratic, I had somebody last hour ask me, what if it touches and bounces back up? That's when it touches and bounces back up, technically x was equal to -6 and x was equal to -6. It touched, bounced back up, so it happens twice, technically. Does that make sense, everybody? Okay. Sweet. Looking at this graph, what's my solutions? Great question. If we had a quadratic that never crossed the x-axis, we would not be able to use solving by graphing. That's when we go to the quadratic formula. Okay, there's going to be a lot of those. So, all right. So here maybe you should just personal finance it then, please. Oh, well, don't complain then. Don't complain then. Okay, here we go. So what's my solutions? X is equal to 3 and x is equal to, okay, here we go. So let's move on. That's pretty easy here. I'm not gonna spend too much time on it. So let's first learn how to solve a quadratic by factoring. We all know how to factor a quadratic now, correct? Yes, so the whole point of learning how to factor a quadratic is so that we can possibly solve the quadratic. How to solve by factoring is first, Make sure it's in standard form. The highest degree to the lowest degree. Ax squared plus bx plus c. Does everybody understand? Next rule, make sure it's set equal to 0. If it's not equal to 0, you need to fix that first. Then next thing, what you do to solve by factoring is you factor it. Then you set those factors equal to 0 and you solve. Okay, so it's pretty easy. So look right here. Could we solve this one by factoring as it is? No, we need to make sure it's equal to 0, so we'd subtract 1 first. Is everybody comfortable with what I'm saying? Then you could continue to solve by factoring. Here we go. Number 15, all my examples are coming off your worksheet. I need your calculators out, ready to go. The quicker we go, the more time you have. As is, we cannot solve by factoring. We need to make sure it's equal to 0. So we're going to subtract by 24 to both sides. So we have 35x squared minus 41x's minus 24 is equal to 0. Now I always check, is there something I can factor out right here, right now to make this smaller? And no, not quite. I mean, because like 41, I don't think anything goes into 41. So we say, okay, I know how to factor a quadratic. What multiplies to be a times c and adds up to be b. So a times c is 35 times negative 24, and that is a doozy. It's negative 840, and adds up to be b, and b is negative 41. Now, secondary 3 just takes dedication. My honors kids were blown away by this problem because of the factors. It took us forever. You can't give up, though. If it's factorable, then it's factorable. So let's list out factors of 840. How you do that is divide by 2, divide by 3, divide by 4. Are you ready for me to list them out for you so we don't have to spend time? So 2 times 420. Color's not very good. 2 times 420. 3 times 280. Do you see how it just takes dedication? 4 times 210. 5 times 162. 6 times 140. Do you see how a lot of people give up at this point and say, oh, it doesn't factor? It does. You just got to be dedicated and keep going. 7 times 120. 8 times 105. Still no. 10 times 84. 11 doesn't go into it evenly, so then we have 12 times 70. Do you see how I'm not giving up? You just got to keep going. 14 times 60, and then I'm going to just go over here. 15 times 56. Isn't that the magic one? Yep. Adds up to be negative 41, but it would be negative 56, correct? 15 plus negative 56. Those are our factors. So now we have to drop and break. Now it's easy. 35x squared. Order doesn't matter, so I'm just randomly going to go with plus 15x's minus 56x's minus 24. Then we factor by grouping. Group the first 2 terms, group the second 2 terms. Factor out the greatest thing in common here. Greatest thing, don't they both divide by 5? Yes. 5x, divide by 5x, divide by 5x. So left is 7x plus 3. X is divided out, 15 over 5 is 3. In common here is an 8. There's a negative in front, so we're factoring out negative 8. Divide each term by negative 8. So then left would be 7x. Look, negative 56 divided by negative 8 is positive 7. Still an x. Negative 24 divided by negative 8 is positive 3. Now look, we factored it correctly. Our safe haven's the same, so we factor out 7x plus 3. So then left would be, so let's divide out 5x minus 8. Now look, I want to say one thing. Linear means degree 1. Degree 1. Isn't this 2 linear factors? Degree 1, degree 1. So we know we are completely done. So we have the product of 2 linear factors. Now our zero product property rule says we can set each of those equal to 0. So we say 7x plus 3 equals 0. 5x minus 8 equals 0. Solve for x in each case. When we subtract 3, 7x equals negative 3. Divide by 7. X equals negative 3/7. Yeah? Add, oh, what happened? You jinxed it, didn't you? Because you hate this problem so bad.
I'm working.
I'm just giving you a tease. But you're crying. I don't know. Does anyone know how come it did that? I'm scared to exit out. Help! What did I do? Okay. Why have you people? Because you're better at technology than me. So then we add 8. So we have add 8 divided by 5. Can I just do that in one step or is that going to confuse people? Okay, x equals 8 over 5. Look, there's our 2 solutions and it took us a wee bit to get there. Questions? Solving by factoring. We factor it down, set the factors equal to 0. Now I'm going to make a point really quickly and I'm going to let you practice. If I say to you, factor, you don't solve. You have to stop here. If I say solve by factoring, you need to go all the way. You need to know the difference. If I say factor, that's not solving. Does everybody understand the difference? Okay, I'll mark it wrong, I pinky promise. Last one, really quick, because otherwise you're going to do it the hard way. Looking up here, it's quadratic. I would not do, though, a times c, because isn't there an easier way? What's in common? 2. And factor out 2x. 2x divided by 2x, won't that be left? X plus 1. Now, isn't that factored? Yep, isn't that degree 1, degree 1? So we set 2x equal to 0. We set x plus 1 equal to 0. Solve for x. When we divide by 2? So x is equal to 0. There's one of our solutions, minus 1. X is equal to negative 1. We're all golden? Okay, do you want to rate? Go. Check with me. Okay, guys, some of you are doing something like this the hard way. Remember, if your a value is 1, you can quick factor it. So it multiplies to be negative 2 and adds up to be negative 1. 1 times 2. This would factor to be, we can quick factor x minus 1 times the x plus 2. Don't do it the long way. You can. It won't be wrong. But you're making it harder on yourself. Do you see how I quick factored it? Then just set each of those equal to 0, so x equals 1, and x equals negative 2. So if you can quick factor it, do it so you get through those much quicker. The most appropriate method, look up here so you're not lost. So if you are missing a middle term, look, quadratics have the form ax squared plus bx plus c is equal to 0. If you're missing a middle term, do you see how this has no bx?
Yeah.
Okay? That's called missing a middle term. There's no bx. You would solve by taking square roots, it's called. It's much easier than factoring. It's much quicker. Another time when you would solve, by taking square roots is if it's in vertex form. A times x minus h squared plus k. You would just simply isolate the square. You would solve by taking square roots. Isolate the square root it, and then so on and so forth. Here we go. First example. Not on your paper, but you could see it on the test. That's why I'm doing it. So we isolate, everybody look, it's in vertex form, right? So we would solve by taking square root. So we isolate the square. We would subtract 18. If you're not watching, you're going to miss it on the test. And I'm going to laugh because I would feel so bad. I tried to make up for laughing at you because I wouldn't laugh at you. But anyways, so continuing. You guys aren't you're supposed to laugh at that. Like awkward, like crickets. Negative 2 times x plus 1 squared is equal to negative 18. Now here's where people mess up. They take the square root right here. You can't do that. You got to isolate the square. So what would we do first? Divide by negative 2. So we have x plus 1 squared is equal to what? 9. Now we can take the square root. So root cancels out with power. We have x plus 1 is equal to 3, right? But now here's where you can't forget. Square root of 9 means what? Squared equals 9. Isn't that 3? But what about negative 3? So you can't forget plus and minus 3. This is where you split it up. We have x plus 1 is equal to positive 3. And we have x plus 1 is equal to negative 3. You see how I split it up? Subtract 1, subtract 1. X is equal to 2. There's one of our solutions. Still subtract 1, subtract 1. X is equal to negative 4. Everybody comfortable with how to do that? Okay. Let's do another one. Number 9. 4 minus 3m squared is equal to negative 28. We would not solve by factoring because notice we're missing a bx, right? Even though there's 3 things, none of them have an m. Just an m, right? So we isolate the square. So we're going to first subtract 4. So we have negative 3m squared is equal to negative 32, correct? Divide by negative 3, divide by negative 3. So we have m squared is equal to, a negative divided by a negative is positive. Does 32 divide by 3? We will try that first.
No.
Nope, so you leave it as 32 over 3. Now, this is where it gets a little bit more advanced thinking. Square root both sides, right? So root cancels out with power. We have m is equal to plus and minus. We can't ever forget that. Now, we do need to split this up so we can simplify it correctly. Technically, we have a square root of 32 on top, and technically on bottom, we have a square root of 3. Is that answer appropriate? Nope. What do we need to do? What's the word for it? Yeah, you're right. Multiply by the square root of 3. Can anyone remember what that's called? Doing what? Multiplying by a fancy one. It's called rationalizing the denominator, yeah? Okay, so we're going to rationalize the denominator. Square root of 3 over the square root of 3. So on top we have, so this becomes plus, sorry, I am like thinking ahead here. Okay, so on top we still have our plus or minus the square root of 32 times 3, which is 96. Yep. All over the square root of 9, which is 3. Then you would check, does 96 break down?
Yep.
To what?
No idea.
I don't think it does.
Doesn't it?
I don't think it does. It does? What does it break down into? 96, what are the factors? Oh, it does. What is it? What? What times what equals 96? 32 times 3, 32 breaks down into? What does 32 break down into? Oh yeah, that's right. 2 times 16. 4 and 4, and we can keep going, but isn't there 2 4s? That's left. Oh, okay. So we have plus or minus. This became 4 square roots of 6. Like you said, 4 square roots of 6 all over 3. Now my question for you, can I take 6 divided by 3? No. Good answer. You're awesome. Questions? Okay. How about, do you want me to go through this one? Nah. I'm going to do it now that you said that. Okay, so, and the reason I'm doing it is for a reason, because you're going to see one on your paper like it. We are missing the middle value, so we would add 5. So you have 2x squared is equal to negative 10, correct? Divided by 2, so we have x squared is equal to negative 5, square root both sides, right? So we have x is equal to plus and minus, oh, can't we pull out an I square roots of 5. Ding, ding, ding. Okay, look at this one. We would add 24, correct? Watch, this one you need, I promise. I have thought through this. I've done the whole worksheet myself and then went and put in examples to help you. So we'd add 24 to both sides, correct?
Yeah.
So we have 4x squared is equal to 25. Then we would divide by 4, correct? So we have x squared is equal to 25 over 4. Now, can that simplify? No. So square root it. If you have a fraction and square roots, we split it up. We have x is equal to plus and minus the square root of 25 on top, the square root of 4 on bottom. Do not rationalize it because that simplifies. What's the square root of 25? 5. What's the square root of 4? So our answers are plus and minus 5 halves. Okay? Now I want you to do 9 through 14. Go. Skip to 9 through 14. Couple things to understand. When I give you the test, I'm going to say solve the quadratic, period. I'm not going to say solve using the quadratic formula, solve using by factoring, solving by this. And you need to use the most appropriate method. So I'm going to tell you when you use the quadratic formula. Are you ready? If you have a quadratic that never crosses the x-axis, that's when you have 2 imaginary solutions. Quadratics have 2 solutions always. Never crosses the real number line, so that's 2 imaginary solutions. And then if it crosses the real number line in like decimal places, that's when we still have real solutions, but they're irrational, meaning can't be written as a fraction. Quadratic formula you'll be using if you have ax squared plus bx plus c, and it has to be equal to 0. Here's the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, okay? I like drop lower there. Now here's the catch. You have to type this in, simplify this correctly. Here's where people mess it up royally. You have to use parentheses just as you see it. Do you see it?
Of course.
Here we go. Problem number 15 on your worksheet. Here we go. So first, it's not in standard form. You can't just float 7 over. You've got to use algebra. Put it in standard form. If you don't, you're going to have A, B, and C wrong. Okay. Now listen up. A is positive 7, B is negative 8, and C is negative 7. So we'd say x equals negative b, I'm going to write it down, plus or minus the square root of b squared minus 4ac all over 2a. Let's plug in what we know. X equals the opposite of b, which is positive 8, right? Plus or minus the square root. You absolutely have to. I pinky promise with cherries on top, put that in parentheses, all this stuff. Negative 8 squared, which is b squared minus 4 times a, which is 7, times c, which is negative 7, all over. Just don't be lazy. It's way worse to get it wrong and have to redo it than to just put parentheses. 2 times a, which is 7. Let's simplify it in sections. So we have 8 plus or minus the square root. I'm going to say something, and I need you to listen very carefully. You do not type in, to simplify this, the square root. The only thing you type into your calculator is this piece. Do not type square root. You won't be able to do it that way. Type that in your calculator, go. Use parentheses, exactly as you see it. You should all practice typing it in, because that's where 99.999% of people mess it up. Don't type the square root part in, just type in what's underneath the radical. You tell me after you get it. What do we get? Did we all get 260? Which problem is this again?
50.
Yeah, 260 is right. Okay, everybody, are you listening? Now this is where you go up all over 2 times 7, which is 14. This is where you go off to the side and say, I'm going to break down 260. So let's break that down. So 2 times 130. 130 breaks down into 2 times 65. 65 breaks down into 5 times 13. Pulling out groups of 2 since it's a square root. Oh, a 2 comes out. That stays, multiply it back together. It's going to be 65, right? So this became 2 square roots of 65. I rewrite it. 8 plus or minus 2 square roots of 65 all over 14. Now I'm going to say one more thing. Only if all 3 things divide by something in common can you divide. So if it was just those 2, still can't. Just those 2 can't. So if all 3 divide by something in common, you're good. They all divide by 2, right?
Yeah.
That becomes a 1, becomes a 7, becomes a 4. So we have x is equal to 4 plus or minus 1 times square root of 65 is just square root of 65 all over 7. There's our 2 irrational. They're real. They're crossing the x-axis. They're just crossing in a decimal place that we would not have ever guessed. Irrational. Can't be written as a fraction. Questions? Let's do another one off the worksheet.
Who decided this first?
I'll get into that another day. Here we go. So we just don't have time, but I do have a lot of information in math history. So we have 7k squared plus 8k is equal to negative 7. It's not equal to 0. We got to algebraically make it equal to 0. So we have 7k squared plus 8k plus 7 is equal to 0. Let's do our quadratic formula. X equals the opposite of b, which would be negative 8, correct? Plus or minus the square root of 8 squared, which is b squared, minus 4 times a, which is 7, times c, which is 7. You get lazy, you get them wrong. It's just that simple. All over 2 times a. So we simplify. I can't stress it enough. Only calculate that in your calculator. If you do correctly, you should get negative 132. All over 14. This is always where you go off to the side and you personally are going to algebraically simplify what's underneath the radical. So 132 breaks down into 2 times 66. 66 breaks down into 6 times 11. And 2 times 3. Careful here. Do not just say the square root of a negative is negative. Wrong. I comes out. We can pull out a 2, correct? That's got to stay, that's got to stay. Multiplying back together, won't that be 33? 2i, we pull out an I from the negative, square roots of 33. So we have x is equal to negative 8 plus or minus 2i square root of 33 all over 14. I'm going to say it again. Only if all three things divide by something in common can you actually do it. They all do. Divide by 2, so that becomes a 1. A 7 and a 4. So x is equal to negative 4 plus or minus I square roots of 33 all over 7. Now guess what? If you looked at the quadratic on a graph, it would be never crossing the x-axis because we have two imaginary solutions. So these are exact answers. They're just a little bit complicated in a simplification. Well, once again, like this is just review, so I'm sorry that I went so fast today. Normally on a normal, like new lesson, they won't be this fast. Once again, we were reviewing a whole unit that took you guys 2 months in secondary math 2 in a day. So I just had to rush, only so that I could give you time in class. Do you want me to do 19 with you, or do you want to just go for it and the rest of the time's yours? Let's have a vote. Who wants to do one more? Raise your hand high. No one. Okay. The vote wins to just have the rest of the time be yours. Ready? Set, go. Up through 24. You talk me through it. Okay. So number 19, we first get it in standard form. So I'm going to bring these both over so I can keep 5 positive. Just preference, I think having an A value of positive is easier. So we have 5x squared plus 2x plus 10 is equal to 0. We know our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's plug it in. So x equals the opposite of b, which would be negative 2 plus or minus the square root of b squared, so that's positive 2 squared, minus 4 times a is 5, times c, which is 10. That's all over 2 times a, which is 5. Simplifying it again. So we get x is equal to negative 2 plus or minus the square root. Once again, the important thing is to only type that part into your calculator. And you should get negative 196, and that's all over 10. So always this is at the point where you go off to the side and you say, I'm going to simplify the square root of negative 196. I'm going to ignore the negative while I break down 96. 2 times 98. 98 breaks down into 2 times 49. And 49 breaks down into 7 times 7. So we're pulling out groups of 2. So there's 2 2s that can come out. There's 2 7s that can come out. There's an I that comes out. There was nothing left under the root. This became 7i. Nope, 7 times 2i. 14i. So I'm going to rewrite it. We have x is equal to negative 2 plus or minus 14i all over 10. And only if all three things divide by something in common can you actually do it. So we can. They all divide by 2. Now don't say that goes away. It becomes a 1. Yep, a 7 and a 5. So x is equal to negative 1 plus or minus 7i all over 5. There's our 2 imaginary solutions. This would be a quadratic that never crosses the x-axis.